Greetings, my name is Simon Mugabi. Differentiation of functions from first principles. In case you're seeing this for the first time, you may want to look at the previous video where I did direct differentiation. We shall discover that the answer we are getting here should be the same answer as one who differentiates directly. Are we together? Okay. Differentiation from first principles. There are 4 basic steps followed when differentiating functions from first principles. The function y is equal to fx. The first step is add a small change in y, small changes on both sides, in the x and in the y and in the x, like the way you see here, small change, small change. Then subtract the y is equal to fx from the established function as in step 1. So I'm going to subtract y. So my y, I subtract the y, but the y is equal to fx. Then divide by change in x. So I have this divided by my change in x. After that, we find the limit of what has been got, and we shall find when we take that limit to the change in x going towards 0, we end up having the derivative. Okay, I'm going to be using these 4 steps, okay, and I'll put them on the side so that where possible we use them, putting them on the side. Okay, but either way you can remember them. We have y is equal to x squared, so I'm going to use to add small changes. So I'm going to add y plus small change in y is equal to the x. On the x is where we add the small changes. Small change in x is squared. Not so, the x is squared. So I add and then I can square. Be careful, you add on the x. So the next thing is I subtract the y. This is the same way as taking this the other side. So small change in y plus y minus y is equal to x plus small change in x squared minus y. But my y, these ones cross, but my y is the same as x squared minus x squared. So clearly this one can be further broken down. Remember, x plus y squared is the same as x squared plus 2 xy plus y squared. You agree? So I can apply this up there. Small change in y is equal to x squared plus 2 x change in y, x plus the y is delta x squared minus x squared. So the x's can now reduce. Small change in x is the same as the x's cross out here. 2x change in x plus change in x this. Now the last step is divide through the second last step, divide through by change in x. So this divide by change in x, we get 2 change in x plus change in x squared, everything divided by change in x. So we end up having change in y over change in x is equal to, the change in x can be factorized out, 2x plus change in x divided by change in x. Please never cross out this directly, because these changes can never be equal. Okay, a change can be mild, can be deep, but we don't cross them out directly. So we end up having 2x plus change in x. So I've not shown how I cross them out. Don't show how you cross them out, but we know they cross out. So we take the change in x towards, as we take the limit, as change in x goes towards 0, our change in y out of change in x will be equal to, will be tending towards the dy dx, and this one also goes to 0. So we end up having dy dx is equal to 2x. This is the same answer I would get when I use direct differentiation. By direct differentiation, I will have y is equal to x. We say the 2 comes down, you get 2x, 2 minus 1, and this gives us 2x. So the answers should be the same whether you use direct differentiation or indirect differentiation. We're going to try out a couple of examples. I hope you find this beneficial. If you like it, if you find it beneficial, please like it. Thank you. I remain Simon Mugabi.